All right, so let's first start with this a nucleotide, okay, right? So what is a nucleotide?
It makes nucleic acids.
Yeah, but what is it? What is it?
DNA and RNA.
Mm-mm. What is a nucleotide? Let me type out these questions over here.
A molecule?
Very good, Ben. What is a nucleotide? Very good. What is a nucleotide? So very good, Ben. So yes, it is a molecule. Very good. So you guys got to remember that. That's number one. A nucleotide is a molecule. Okay, so that's what you need to understand. Okay, number one. Okay, and so when you say, Liz, that it's DNA and RNA, right? It's not. That's not correct. All right. Now, Anissa, what are molecules made out of?
Atoms.
Very good, right? So we know already that, okay, since a nucleotide is a molecule, then what's a nucleotide made out of?
Atoms.
Atoms, exactly, right? And so the atoms that we're talking about, the atoms that you're gonna find in a nucleotide are the atoms we talked about last semester, but you're also gonna have a P in there, okay, for phosphorus, okay? So an atom, so atoms have over the billions of years, what ended up happening is, okay, through evolution or whatever, okay, atoms came together to form these molecules called nucleotides. Okay, so they're little molecules. All right, little molecules, very little molecules. So nucleotides are small molecules. Okay, now that's number one. So write that down, Anissa. Write it down, Ben. Write it down. This stuff you need to be writing down. Okay, this stuff you need to be writing down. And I don't have my coffee. Dang it. What do you guys drink in the morning? Hot chocolate? Leche?
My mom told me this drink. It's called Avena.
Avena? Oh, that's good. See, that's how you know you're really Mexican. When you're drinking Avena, you're Mexican. Okay, you know Ben had some pan dulce, huh? I know he did. Okay, so you can tell in his cheeks. All right, so now, so atoms form molecules, and there's these very special molecules that form, there's these very special molecules called nucleotides, okay? Now, before we go on to this, let's review a couple of things, okay? Number one, a cell. What's a cell made out of? So remember we talked about the 4 ingredients to making a cell? Okay, what is a cell made out of? What's the outside made out of?
Lipids.
Very good, lipids, right? So remember, that's why I had a bunch of L's last time. Okay, there's these molecules called lipids, all right, that make up the outside of the cell, and then also they make up like the organelles and stuff. But that's what the cell's built out of, molecules, lipids. Good. So lipids is one. Good. Now, there's these other things called that I'm going to put a G in there, right? A G. And what are the Gs? What are the molecules that start with G that cells have inside of them?
Glucose.
Glucose, not guanine, glucose. And so why do they need glucose? Why do cells need glucose?
Energy.
For energy, that's right, to make the ATP, right? So now we built the cell. Think of it like all the wood, like if we're building a house, that's the wood that the house is made out of. And then the G is what allows the cell to get the energy, right? And then there's these other things called that I use P's for. What are the P's?
Protein.
That's right, proteins. Very good. Right? And so cells have proteins, And we said proteins are like what? What are proteins like? We used an analogy the last couple times.
Apps.
Apps, exactly. Think of proteins like apps, right? And like if two different apps do two different jobs, right? So that's the idea. Proteins are apps. They do jobs for the cell. Okay, so make sure you understand that. But now, the last one is, and probably that's what our discussion was about, right? This guy. All right, what's this guy?
DNA.
Exactly, DNA. Now, DNA is a type of what?
Nucleotide.
No.
Macromolecule?
It is a macromolecule, you're right. Okay, so this macromolecule, this big molecule, what family of molecules does it belong to? It's a good question for tomorrow. So if you guys don't know the answer, that's how I know. What family All right. So, any ideas? That literally the answer is in the word. It's like D, think of, right? So this thing is DNA, right? Think of Na.
Nucleic acid. I don't know.
Exactly. So DNA is a nucleic acid, is a type of nucleic acid. So cells basically have these four ingredients. Okay, so to make a cell, you need these four things, right? So we haven't really talked about lipids too much, but we spent a bunch of time talking about glucose and ATP. We spend a little bit of time talking about proteins, right? And now our discussion right now is nucleic acids. Okay, that's what our discussion is about right now. What are there's two types of nucleic acids. What are they? What are the two types of nucleic acids?
DNA and RNA.
Very good, right? There's DNA and RNA. Very good. So these nucleotides, right? These nucleotides are used to build DNA and RNA. You understand? That's how this works. So when I asked you what is a nucleotide, and you said it's DNA and RNA, right? So that doesn't make sense. Think of these guys like skyscrapers. All right, so this guy's a skyscraper, this guy's a skyscraper, right? And so then I said, and then this is like a piece of metal, like one piece of metal. All right, so basically when I said, okay, what's a piece of metal? You're like a skyscraper. See how you don't understand like the relationship? Nucleotides it's just a building block for these things. So you can't build RNA or DNA if you don't have the building block, the nucleotide. So you guys got to understand that difference, that you need these molecules to build these two macromolecules. Okay, you understand? That's the idea that you guys need to understand, okay? Now, why do cells need nucleic acids? Why do cells need nucleic acids? What do you guys think?
Make DNA.
Do cells need nucleic acids? Okay, basically, Ben, this is what you said. This is basically your answer, okay, buddy? If I would have asked you, basically this is what I asked. I said, why do cities need skyscrapers? And you said to build more skyscrapers. That's basically what you said. So let me rephrase that again. Why do cells, think of a cell like a city, right? Okay, why do they need nucleic acids? Remember, DNA and RNA are the nucleic acids. So in other words, why do cells need DNA and RNA? Why? Why do cells need these two guys? And we talked about this already. See how you guys fall asleep in the big group discussions? What do you think, Anissa? Come on, this is on YouTube. You guys are embarrassing me right now. We're actually live right now. Anissa's lagging. So what do you think, Elizabeth? Remember we talked about this. Remember the idea of apps. In order for you to have an app on your phone, what do you need?
Codes.
Codes. So DNA stores the codes so that you can have these apps. Because you can't have these apps unless you have the codes to make them. Does this make sense? Yes, no? Okay, that's how this makes sense. So for example, if your cells need, for example, to make energy, then there's a code in the DNA so that the cell can make a protein that's going to make energy. Okay, there's cells, like for example, let's say your cells need to duplicate. There's codes in your DNA so that the cells can make proteins, okay, to help the cell duplicate. So nothing happens inside the cell without a protein being involved. And these proteins don't exist unless we have the codes to make them. Does that make sense? It's just like your phone. Your phone, okay, you can't have an app on your phone unless you download the codes from the app store, right? The same thing. That's why DNA is so important, because it stores the codes that the cell needs. Write that down. Write that down. Write that down. All right? Make sense? Yes or no? So now that we understand this, right? Now that we understand the big picture, right? Why nucleotides are so important, why nucleic acids are so important, because they store the codes. Now we need to understand these guys even further so we know, so we can understand how they store codes. All right? And so now the first step is understanding the nucleotide. Okay? So what does the nucleotide look like?
Doesn't it have 3 parts?
Very good, right? It has 3 parts. Very good. Okay, and so if I had to draw a cartoon version of it, it looks like this. It looks something like this. Okay, this is what a nucleotide looks like. Okay, it's a very small molecule. Okay, it's a very small molecule. All right, and what are these three parts called? What's this one called?
Phosphate group.
Phosphate group, good. What's this one called?
5
Oh, no.
carbon sugar.
5 carbon sugar, very good. And then what's this guy called?
Nitrogen base.
Good, the nitrogenous base, very good. Very good, very good. So now, these are what these nucleotides look like. Right? And remember what I said last slide. I said that nucleotides are like pieces of metal, right? Okay, right? So you need these to build these guys. And so this guy right here, you need these guys to build these two guys. That's how this works. Okay? And so for the test, okay, what's really important is for you to understand what a nucleotide looks like. Okay, why are nucleotides, what a nucleotide looks like, and then understanding the big picture over here. Make sense? Okay, questions on this so far? Questions? Questions? All right, the last thing I'll leave you guys with is this. So if we Google a nucleotide, right? Nucleotide, right? So let's Google nucleotide. Okay, so here's the images here. Look at some images. All right, and so this image is this is a pretty good image because you can see, whoops, you can see very clearly, right, watch. This one's a good image because you can see the nucleotides. So here is one nucleotide. See, 1, 2, 3 parts. This is another nucleotide. Here is another nucleotide. See that? Okay, and so this whole thing is what? The whole thing is what? If each one of these is a nucleotide, then the whole thing is what?
DNA.
DNA, exactly. So DNA looks like this. It's made out of nucleotides that are connected together. Okay, so that's very important that you guys understand that. Okay, and then that's why when I draw it, that's how I draw it, right? And then a nucleotide, remember, it's a molecule. So if you guys, I know that Elizabeth has models of it, so you actually can build this. You can build one of these. And in the video, I showed you guys these molecules, okay, very extensively. So for example, right here, here's a phosphate group. See how this red marble is connected to the black marble and there's 2 hydrogens, right? What are these things right here? What atoms are these?
Carbon.
That's right, they're carbons. So this guy right here is a 5 carbon sugar, 1, 2, 3, 4, 5, because that's why it's called a 5 carbon sugar, because it literally has 5 carbons, right? What sugar is this, by the way? It has a specific name. Did you guys catch that from the video?
Deoxyribose.
Very good. It's deoxyribose. Excellent job. Right? Because it's missing this extra O. Very good. And then right here, don't forget, this one has carbons as well. And this thing right here is probably the most important part of the nucleotide. It is the most important part of the nucleotides with respect to codes. Okay, and this is a nitrogenous base called adenine. Okay, does that make sense? So I want you guys to really understand that a nucleotide is just a very small molecule, and that you need it to build DNA molecules. Okay, does that make sense? And so there's actually like businesses now that are going to become like very, very important in the future, and their job is to work with DNA and build DNA and figure out and read codes and manipulate these codes so that they can help with like different genetic diseases and stuff like that. And so that's where a lot of the money in medicine is going to come from this work with DNA. It's called genomics. Okay, so that's the big things that I want you to learn from the video today. Okay, these main concepts. Any questions, concerns on this? No, you guys are good? All right, sounds good. All right, so stop sharing. Good. Actually, did I stop recording? All right, so let me share again. Hold on. Share. All right, so